So, this video is going to explain kind of what's going on for the rest of the week. So, the quiz you were going to have on Tuesday, you're going to have something similar to it on Thursday, which would be tomorrow. It will be over primarily F versus T graphs, those impulse graphs, and then some P equals MV problems mixed in with the F versus T graphs and things like that. So, um, that uh, force versus time worksheet 1 through 6 that you did would be an excellent resource to study. Also, if you wanted to go back, I'm going to link those two videos that I made earlier in the week. I will put them. They will be on today's date as well, so that you can kind of look at those and rehash those. So the quiz will be about 20 points or so. It will be through Canvas now instead of on paper. And we'll just kind of see how that goes. All right. I will probably also let you take it, like do one retake if you would like. Keep in mind the uh, Canvas will keep your most recent score, not necessarily your best score. So take if you take it a second time and you do worse, it will take the most recent score. So it will take the lesser of the two scores. So just be aware of that. We'll try to then do the test on Friday um, of this week. And so after the quiz tomorrow, we will review, and then take the test Friday. All right. And then I will try to make um, some sort of review guide or something for you so that we can figure that out. Again, the test will be on Canvas. It will have to be at this point. If we take a look at what I have down here, so down here is uh, a problem that is uh, reminiscent. This is what your bonus on the test would look like. Okay, so there will not be anything like this on the test, um, other than in a bonus situation. So um, that's what we're kind of looking at here is how do we do this one? So um, what I'd like you to do is I'd like you to take a look at this and see if you can come up with a strategy to solve this and see if you can solve it yourself without without me helping. All right. So what I'd like you to do is hit pause here in just a moment, solve it, and then um, see if you hit play and then see if you get it right. Now, one thing keep in mind. So I've kind of drawn this here a little bit. Cue ball has a mass 50 grams, struck perfectly horizontally, glances off this ball that has a mass of 75 grams. It is initially at rest. All right, I should have said that in the problem, but it's not. So then after the collision, the cue ball is deflected up with an angle of 30 degrees above the horizontal, and the pool ball is deflected down at some angle. We don't know what it is yet. And you're supposed to figure out the velocity of this pool ball. All right. So right now, go ahead and hit pause and see if you can figure out a strategy and solve for the velocity of the pool ball. All right, so how would we do this? Well, this would be conservation of momentum easily. All right, and this is definitely a closed system. All right, the only forces are going to be from the impact of ball A hitting ball B and ball B hitting back from ball A. There's no other outside forces. So we don't have to worry about anything there. And so really what we're going to use here is that the initial momentum is equal to the final momentum. All right. Now, we happen to know what the initial momentum is because we have ball B, which is 0. The initial momentum over here before the collision is just the mass of that ball times its velocity. And that's pretty simple to figure out. It's 50 grams, so we have to convert that to kilograms, move the decimal over 3 times. That's 0.05. So 0.05 times its velocity, which is 8. Multiply that together, and you get 0.4. All right, and 0.4 Newton seconds is what I'm going to call it. All right, so that is the initial velocity. Well, the good news is that means that's what the final velocity is. Now, here's the other thing. This 0.4 Newton seconds is all in the x direction. None of it is up and down. So it's all this way, which means that's what it must be here too. All right, that will be very helpful. Okay, so how do we go about solving this? All right, so what we first got to do is we got to remember that momentum is conserved. There's no law of conservation of velocity. There's only law of conservation of momentum. So just because the velocity here is 5 doesn't really mean anything. It's the total momentum that is conserved. So what I need to do is I need to find the momentum here. Well, the mass is 0.05 times 5, all right? And when you take 0.05 times 5, you get 0.25. All right, so the momentum of the ball at the angle is 0.25, and that's Newton seconds. All right. Now what we're going to do is we're just going to treat this like a vector. Okay, we're going to draw on our components, and we're going to solve for our x and y components. All right. Now, when we do that, remember this angle right here is 30 degrees. All right, it's 30 degrees above the horizontal. All right. So using what we know about SOHCAHTOA, this is our hypotenuse. We ignore the 5 meters per second. All right. Because like I said, momentum must be conserved, not velocity. And so when we do that, all right, and we take the cosine of 30 degrees and multiply by 0.25, we get the x value to be 0.216 Newton seconds, and the y value comes out to be 0.125. All right. Now, what we know has to happen is that the final momentum has to equal the initial momentum. So if we take a look here, make a little t-chart, all right? From the cue ball, my x is 0.216 and my y is 0.125. Well, from the pool ball, right, these things have to add up to 0.4 in the x direction, because that's what it was, and 0 in the y direction. It must be 0 in the y direction because initially there was nothing in the y direction. So my y value is easy. It's negative 0.125. So I know that this is 0.125 down here, and that's my y value. And then my x value is going to be whatever 0.4 minus 0.216. So I get 0.184. Well, those are my components then for this. So that's 0.184. So now if I do some SOHCAHTOA and find that angle, which I can by using the inverse tangent, all right? And so inverse tangent of 0.184 over 0.125, it's a 4, all right? We get 56 degrees. So it's 56. We know that angle is 56 degrees now, right? But we still don't know the velocity, and that's what they're really asking for. Well, again, I have two momentum vectors, all right? So what I can do is I can find that resultant as momentum, okay? So I'm going to do that. And so I'm going to take 0.125 squared. I'm going to add that to 0.184 squared, square root that, and I get 0.222 Newton seconds. And that is the resultant momentum. Now, if I want to find the velocity, well, that's simple. That's just mass times velocity. The momentum is 0.222. I know the mass is 75 grams, which is 0.075 kilograms times the velocity. And so what we get is 0.222 divided by 0.075. And we get the velocity comes out to be 2.96. Now, that'd be meters per second, right? Now, the velocity is going to be in the same direction as the momentum. So we already calculated that angle, and that was 56 degrees from vertical. So that's probably not the way we want to describe this. We probably want to describe this from horizontal. And so if we subtract, take 90 degrees and subtract 56, we get 34. So this is 34 degrees, we would say below horizontal. Hold on, let me move. See if I can get all that on there. That's supposed to say horizontal. So that would be my answer there. So again, it's really no different than any of the conservation of momentum problems we've done before. We're just adding in some different directions. Basically, we're just combining this with a vector problem that you've already done. And that's the answer that you should get right there. All right. Like I said, that would be a bonus problem and probably nothing more than just bonus on the test at this point. All right. That'll be all we have for today. Remember, quiz tomorrow. Quiz will be mostly graphs and things of that nature. So study up on that. And then the quiz will be written in